Hello everyone. In today's video, I am going to teach the calculation of arithmetic mean in different types of series. So, first of all, the arithmetic mean represents the entire data by one value, which is obtained by adding together all the values and dividing this total by the number of observations. That is, the sum of all the observations divided by the total number of observations. So, there are different types of series to find the arithmetic mean. The first case is calculation of arithmetic mean in a series of individual observation. So in this, we will be given just a set of all observations. Like if we take an example 7, 6, 8, 10, 13, 14. So to find the arithmetic mean of this set of all observations is the sum of all observation divided by the number of observation. That is called as direct method. This method is called direct method. That is sum of all observations 7 plus 6 plus 8 plus 10 plus 13 plus 14 divided by the number of observations. Here there are 1 2 3 4 5 6 observations, so this equals 58 by 6, which is equal to 9.67. So the other example is find the arithmetic mean of the data 10 11 10 11 9 7 9 11 12 20. So if we use direct method, what we do, we take sum of all these observations 10 plus 11 plus 10 plus 11 plus 9 plus 7 plus 9 plus 11 plus 12 plus 20 divided by the total number of observations 1 2 3 4 5 6 7 8 9 10. So this sums up to 100 divided by 10 equals 10. Therefore the arithmetic mean of this observation is 10. Okay, so in some cases, like the number of observations are very large. In that cases, we use the another method of finding the arithmetic mean is assumed mean method. So let me explain this method by taking one example. Suppose if we have a set of all observations, for example 18 20 21 19 28 22 29 30 31 35. So if you can see these numbers are very large, we can use assumed mean method. So in the assumed mean method, we choose an arbitrary number as a assumed mean. We can assume an arbitrary mean. We can choose any number as a assumed mean. So let me list this data in an order first. 18 19 20, 21, 22. After 22 I have 28, 29, 30, 31, 35. So in the assumed mean method, what we do is we select first assumed mean. So in this case I am choosing assumed mean as some number 24. I can choose 25 also, no issues. I can choose 18 also, no problem. I can use 35 also, no problem. You can choose an arbitrary mean. So I am choosing 24. Now what I will do is I am going to find the deviations from the assumed mean. So deviation, how far it is, the given observation, how far it is from the assumed mean. So what I will do is I will subtract that observation from the assumed mean. So I get 18 minus 24 is minus 6. Then 19 minus 24 is minus 5. Then minus 4, and this goes to minus 3, minus 2, and this will be plus 4, 5, 6, 7 and 11. Now what I should do is I should find summation of d, sum of all the values of d. This will be get minus 20 plus 33. So summation of d is 30. So now what is the formula of the arithmetic mean using assumed mean is a plus summation of d divided by number of observations. Here I have assumed mean is 24 plus summation of d is 13 and the number of observation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you add all these numbers, so the answer is 25.3. So the arithmetic mean is 25.3. You can use direct method also, you will get the same value. Okay, so this is the formula of finding the arithmetic mean using assumed mean in a individual series. Okay, next the second types of series is discrete series, that is a calculation of arithmetic mean in discrete series. To find the arithmetic mean of discrete series, what we will do is the values of the, it's just a hint for finding the arithmetic mean in a discrete series. It's like the values of the variable are multiplied by their respective frequencies. Here the what is the number of total number of observations? Here the total number of observations are equal to the total of the frequency. The formula finding the arithmetic mean of discrete series is x bar is equal to summation of fx divided by summation of f. Summation of f is nothing but the total number of observations. Summation of fx is nothing but the number variable and the frequencies are multiplied, then we added, that is sum of all observations. So this is called as direct method of finding the arithmetic mean in a given discrete series. If I take one example, like let us say number of chlorophyll plants, chlorophyll deficient plants, and here the number of plants. The number of chlorophyll deficient plants are 0, and the frequencies, there is no deficiency of plants, are 34. There are 34 plants, those have no deficiency, and the number of chlorophyll deficient plants are 1. The frequency is 14. 1 represent the number of deficiency, chlorophyll deficiency is 1. Those plants are in 14, and number of deficiency is 2. The number of plants having 2 deficiency is 20. The number of deficiency is 3. The number of plants having deficiency 3 is 24, and like that we have this set of observations. Now we have to find the arithmetic mean. You can use the direct method, formula x bar. So to do this, what we should do is we should multiply this x and this f, that is fx. So we should multiply this to find the arithmetic mean. That is 34 into 0, 34, 14 ones are 14, and 20 twos are 40, 24 threes are 72, 25 fours are 100, 33 fives are 198, sorry 195. Okay, fine. So I already told the number of observations is nothing but the total of the frequencies. Here the total frequency is 538, so it would be 0, 150. 150 is the n value, number of observations. So here summation of fx is 391. If you use, now we have to use the formula of arithmetic mean, this one. So summation of fx is 191 divided by 391 divided by 150. Therefore, the arithmetic mean will be much, it will be around 2.61. Okay. Now let me take a different cases where having a large number of observation. If I have a large number of observation, in that case we need to use the assumed mean method. Okay, let me take that example. The question is like this. Okay, the question is like this. Number of leaves, and here is number of plants. Number of leaves is, when the number of leaves is 5, there are 6 plants having 5 leaves. If there are the number of plants having 10 leaves are 5, like that it goes on. 15, 25, 30, 35, 40. So 6, 5, 9, 4, 3, 6, 4, 3. So let this be f, frequency, the number of plants, and this is x. Okay, so I can see these numbers are very large. Okay, the observation is very large. So what I will do is I use a assumed mean method. That by assuming assumed mean as some number, any number I can choose. So I choose 25. So what I should do is, now I should find the step deviation of. So the the deviations of the variable x from the assumed mean. Okay, here d is equal to, as I earlier told, x minus a. So assumed mean is 25. 25 is a, 25 is a. So 5 minus 25 is minus 20, and 10 minus 25 will be minus 15, and so on. We get these values. So these are the values of deviations from the assumed mean. Okay, so now what I should do is I should multiply f and d. this because I am multiplying the frequency and the deviation because the series is a discrete series. In a discrete series we multiply variable and the frequency, but when the number is large, when the x numbers are large, then we find deviation. Okay, so that our calculation will be easy. Therefore f into d will be 620 is 120, that is minus 120, then minus 75, then minus 90, then minus 20, then 0 into 3 0, 30, 40, 45. Though we know the formula, x bar, when we are using assumed mean, what we do is we add the assumed mean value plus summation of ft divided by the number of observation is what? It is sum of all the pre-frequencies. So here I have taken the assumed mean as 25. Now I have to find the summation of f into d. This will be almost 5 5 is a 10, 0. Okay, so it will be 190. It will be minus 190. It will be minus 190. So summation of f is 6 plus 5 plus 9 plus 4, and this totals up to 40. So 25 summation of fd is minus 190. You write minus 190 only, don't neglect the negative sign in assumed mean value. So summation of f is 40. So 25 minus 19 by 4, this value will be up to 25 minus 4.75, this equals 20.25. This is the arithmetic mean of the discrete series. Hope you all enjoyed the class. Hope you all learned. So thank you.